Yeah, as Robert mentioned, amongst the other things that I've done in my career, I had the privilege to lead the simulation group at Ausenco. That was the group that Harry founded. That was the place that Jomsom spun out of. And I didn't overlap with Harry. I came a few years after he left. And I didn't actually really start a dialogue with Harry until a couple of years after that. But what I was really fortunate to have inherited when I took on the role was like an incredible legacy of simulation projects, um, probably more than 400 by my count. A great team of experienced, seasoned people that had done this for a long time, and a world-class methodology for undertaking simulation studies. And so today, my plan wasn't really to sort of go into depth in a particular simulation. It was more to just talk about some sort of insights that I gained, uh, uh, and in what I did, and the primary focus of the type of simulation work that I was involved with was not completely, but mainly modeling supply chains, both in the mining industry as well as the oil and gas industry. And so that's where my sort of talk is based upon. So I wanted to, and the other thing to note is that all of our projects were done using basically TLS, which Harry described in his keynote. It's a set of proprietary libraries that was originally developed that run on top of JOMSIM, and that now Harry is kind of like redone in terms of JOMSIM Pro and improved a lot of the capabilities. And that also as a company, we were beneficiaries of all the upgrades that kept coming through the Jomson uh, the free version of Jomson because that's what our software was based upon. So we kept getting all these free feature updates, which was fantastic. In any case, I'm going to just kind of give a couple case studies to sort of give you a flavor for the type of work that I did, and then just talk about a few lessons learned, um, and then maybe some areas where I don't see dynamic simulation in the resource industry being used as much as I believe it should be. Um, so let me see if I can go to the next slide. Oops. So first, I wanted to give this context of why we should pay so much attention to supply chain disruptions because often as an engineering company, we're asked to optimize the throughput of a system using simulation or at least inform the design. But we don't often think about like ultimately the cash flows that will be disrupted if the supply chain isn't designed well, right? If there's flaws in the supply chain that lead to disruption. And so giving you sort of this hypothetical example, it's based on a real company, Elk Valley Coal, which mines 25 million tons per year of coal in Western Canada, um, basically in the interior of British Columbia, in the mountains, and then moves most of that by train to a few different ports on the west coast of British Columbia. Um, but this is by no means like their particular financial situation, but based on today's coal prices, a one-day disruption of their supply chain will cost them $8 million. Now, that kind of disruption it happens once every year or so. Typically, some sort of labor dispute that gets solved very quickly. A 1 week disruption can would lead to a $50 million shortfall. And that happened a few years ago. There was a really large weather event, an unusually large rainfall event that they called an atmospheric river that hit British Columbia, and it shut down the rail corridor that goes from the interior of BC to Vancouver for 9 days. And so that was a big deal for companies like Elk Valley who service that coal. And so something like that in today's coal prices would cost them 50 million. And a 1 month disruption, while potentially very rare, $210 million. So these are big numbers. Um, and of course, these are unmitigated numbers. So if you could use simulation to justify risk mitigation measures and show that it pays off on a risk-adjusted basis, then you can make adjustments to your supply chain. You can use simulation to anticipate and make adjustments. So what we really want to do is be able to have some objective tool to understand what the impacts of disruptions would be, and then use the tool to play around with it to sort of test different investments to offset or mitigate that risk. All right, so just a couple case studies to give you a flavor of the type of work that Ausenco does and others do using basically JOMSIM, Ausenco's version of JOMSIM. So this is a feasibility study. So this is all taken off the Ausenco website. I'm not giving away any sort of proprietary information here. This is a case study taken directly from the Ausenco website. This was the Baffinland iron ore project. So it's a mine in the Arctic Circle on Baffin Island, and it mines 8 million tons of iron ore per year, and they have a big project to take it to 22 million tons per year. So a very much larger operation. Ausenco was engaged in the feasibility study of the new port. So the new expansion would require a rail line. The mine is up here where my red pointer is, if you can see that. And the new port that they would have to use is down here, 150 kilometers away. And so the project was really to design the port and all the necessary infrastructure along the way in order to do that expansion. The other sort of interesting components to this kind of a supply chain is that because it's so far north, they can only export seasonally. So it required some unique sort of storage, and storage was a big deal. Was there enough capacity at the loadout area to basically store, 6 to 8 months worth of product? So this is just sort of an example of the kind of project we did. The simulation. So this was a feasibility study carried out by engineers across Ausenco in different fields, process engineers, material handling engineers, marine engineers, and the simulation study was really used to inform the decisions they were making and test them and make sure they made sense. Just do the next case study. Another example of a notable supply chain simulation that Ausenco has worked on for years is the Trans Mountain pipeline expansion. So Canadians who are on this call will kind of know this is a notable project because it was first announced in 2012. It's an existing pipe. It was an existing pipeline that connected the oil producing province of Alberta to a port in Vancouver, and the plan, which has just now been implemented, was to triple its output capacity. So it used to roughly transport 300 million barrels per day, 300,000 barrels per day, and now it transports, I believe, 980,000 barrels per day through the twinning process. So it was a big project. It had a lot of, I could go on for a long time, but basically it's a very big and important project right now for the oil industry in Canada, and it's especially getting a little bit more notoriety because Trump's tariff announcement has Canadians sort of wanting to export more oil to world markets themselves, as opposed to sending most of it through the United States, which is what happens now. And the Trans Mountain Pipeline is an example of how we get our oil to world markets. In any case, the the project went on. The model was used throughout the phases of the project. It was used in the test, the design, and do optimization and feed. And then later on, it was used to test as the project got closer to inception. It was used to test contractual arrangements with shippers, long-term contractual arrangements. It's also been used to test like changes to port rules. So the sort of point I wanted to get across is that a model like this, once it's built, you keep coming back to it. It's a holistic supply chain that models all the different aspects of the operations to get the product from its source to the market. And what we usually find is that clients keep coming back to it for different reasons. It takes on a life of its own. Okay. So the one thing that I've sort of been involved with a lot, as Craig mentioned, are feasibility studies. So in the mining and in the oil and gas world, those are studies that are done to justify investments. And there's actually, as Craig showed on his slide, there's a number of studies that get done, starting with a concept study, then a pre-feasibility study, and then a feasibility study. And then you get into like the design, and finally you get, the final investment decision, and you go and build the thing. So these decisions can take years. These studies can go over long periods of time, and typically where we usually would get involved in a study like this in terms of simulation would be at that feasibility level, or sometimes even at the basic design level, so the next level up. So at this stage, at those stages, actually a lot of design decisions have been made, and they want you to come in with a simulation model and basically maybe do a little bit of optimization, or often just sort of confirm that, yes, this design works. But at that stage, you have a lot less sort of ability to really affect decisions. So it really kind of gets into my lessons learned. And this is where we went over the time that I was at Ausenco, was really advocating to start the modeling process earlier. So often the pushback I would get from engineers and clients would be, well, you don't have enough data. We're just doing a concept study here. We're doing a pre-feasibility study. You don't have enough data to build a simulation model. And I would say that's fine. Let's build it anyway. Let's build it with the data that we have. Let's keep it simple. Let's make assumptions where we don't have data, and let's just test the supply chain and see what we see. And so that actually has paid off a number of times. So I recently had been involved with a project in South America, which was a mine to port study. So it was a mine rail port of a large copper project. And we were there to inform the design of the mine and the port, and that there would be a rail provider that would provide that transport service. And we went and we convinced the client that the very first thing we should do is build a model before we get into any design, and just start populating the model with high-level assumptions. And that actually paid a lot of dividends, because we showed through a simple model with sensitivity analyses that the rail had a big constraint. There was a big problem with that rail. And had we not done the sensitivity analysis, we would have progressed the engineering on the port and the mine further than we had to. And what came out of that was like really pointing to the client that, hey, we gotta sit down with the rail provider, or it wouldn't really make sense to progress this project any further until you resolve these issues. So so number one is lesson I would advocate for is start your modeling early. And then the second, if you're going to start early, my next lesson is plan for iteration. So, the great thing about these simulation models, and as I alluded to when I talked about Trans Mountain, is that you keep coming back to it and improving it and incorporating more detail and realism as the project goes from its concept through its design, finally to delivery. And if you do it right, this model can keep going along that path and ultimately become an operational tool. And there are clients that I worked with. We did deployments for clients where after we did the modeling for them for their design purposes or for their decision-making purposes, they took it in-house and they use it operationally. The third lesson, I would say, is that a lot of modeling of supply chains goes along shared infrastructure. And so I can think of a lot of examples of this where we get incorporated to model, or we get commissioned to build a model of a supply chain for a client. Usually the client is the resource producer, like a mining company. And they're going to have to work with all these stakeholders to get their project to market. Often there's other mining companies in that same region that have to work with that same stakeholders. And in some cases, well, in a lot of cases, these are remote regions where transport corridors actually need to be built, where they don't exist and they need to be built. And in those cases, everybody has a shared interest in that infrastructure. And what we saw is, what I've seen a lot of, is that people go and they do their separate models. No one has the full information. Each person has their own information. And when you're the consultant building the simulation model, you're basically going to your client saying, give me all the assumptions about how your competitors are going to operate, or how your the other stakeholders in the area are going to operate. And there become a lot of assumptions. So the best thing to do is partner with them, in my opinion, and get a better outcome. Another case that I can think of was a terminal and a shipper that were looking at making a joint investment decision that would have potentially, or will potentially, improve both their businesses. They actually commissioned us separately. We built two different models of the same system for the shipper and the terminal because one of them was reluctant to share data with the other. And so by doing so, we said, okay, we're not using the other data. You have to give us your data and your assumptions. And the two different models told different stories. Eventually, they realized that they should get together. And we had a few workshops with them, and we redid the modeling to basically incorporate everyone's data. And the story there is that no one had all the data. So the terminal was making assumptions about the shipper's business, and the shipper was making assumptions about the parts of the terminal that they didn't know about. So working together and incorporating your stakeholders to work with you, it's great. It's good. Another lesson to take forward. And finally, so communicating results visually. So it's been talked about a bit. Well, Craig's obviously incorporated visualization to a high degree of success. And Avril mentioned it too. The computers are so fast, and with multiple cores, or if we deploy to a cloud, we can even run more at a time. We can, and we did regularly run thousands of simulations to analyze scenarios for clients. So what we do is for the purpose of optimization, there can be a lot of decision variables that we want to manipulate to see what combination of decision variables give you the most optimal outcome. And simulation is a fantastic way to do optimization if you have that speed and capability. And it gives you the opportunity to explore this really large solution space of possibilities, see what worked well, see what didn't work in terms of combinations. The sort of downside to that is you get, like, each simulation produces so much output data such a rich data set. And then when you run thousands of them at a time, exploring that output data can be very onerous. So one thing that we started to do a lot of uh, during my time at Ausenco was use visualization tools. Particularly, I'm a fan of Tableau, but it could be some other business intelligence tool to really sort of like tell the story of the simulations visually. So both from our own perspective to explore the results we're getting, make sure we understand them, and then to provide these rich stories to our clients in terms of the different ways to look at the results. So finally, I guess just to sort of summarize where I've seen simulation used a lot of in supply chain, in sort of like optimizing supply chains, is typically the standard question is to validate the throughput of the design or to optimize the design. And usually that's done, as I mentioned, at the feasibility study, uh, and it's used to drive an investment decision. And a lot of times what we see is that like we go through this process, maybe a 4 or 5 month process. Oh, could be a couple months to few 4 months to build this really sophisticated um, model of the supply chain to affect an investment decision. And then after that, the model gets shelved. Sometimes it gets dusted off in the commissioning phase, so that's not uncommon, but it was less common to see that model come back when the company is going to commissioning and use the model for an additional phase of optimizing operations. So, testing and validating operational philosophy, looking at a more granular maintenance and spares analysis, as well as resource scheduling. What I didn't see a lot of, and where I think there's a lot of opportunity is using the model in a commercial optimization perspective. And that would be, and we got into this a bit, but I would say the vast majority of studies are um, you know, the corporate doesn't really get to see this, or when the corporate does get to see this, they don't think about that this is a tool that you can use to overlay the economics of your business, and you can use it to test contractual strategies or product strategies and blending strategies. You can use it to analyze hedging, like hedging of commodities to reduce price risk, and other types of commercial risk mitigation measures. So that's been my experience. Those are my lessons. And if we have any time, I'm curious if you have any thoughts.
Thank you very much, Jason. Are there any questions for him on the strategies about building supply chains?
I can't see if there's any questions or if anyone just has any comments, like
Oh, we
maybe
got
you have a
one.
different experience.
So there's a question here from Anthony. Have your stakeholders been surprised with the outcomes of the models in terms of where they, uh, sometimes maybe companies will contract with you to uh, corroborate what they suspect. They feel like they've got two options. Maybe option A they're leaning towards, but they want you to come in and kind of give them the data that they need to make their decision. Have there ever been any surprise outcomes or learnings that kind of took you back to maybe square one or anything out like that?
Well, certainly, yeah. I mean that I would say that that happened regularly, where there was a lot of learning and insight that came out of the model. Um, I'm trying to think right now on the spot here about a time when it took us all the way back to square one. There's certainly been times that, the modeling was very insightful in terms of looking at different options and proving out results. Many times where, I guess after the fact, clients would look at the results and sort of intuitively agree with them, but beforehand, it wasn't obvious. And certainly the case that I mentioned of the project, the copper project, where we sort of identified very early on about the rail bottleneck. That was very insightful, actually. That wasn't expected. That wasn't expected by our own team, and it certainly wasn't expected by the client. Um, and it was just a matter of like taking a few sort of like constraints on the rail system that we knew about, that the client had told us about, and overlaying that on top of how the operations would run at the mine and at the port, and then realizing, yeah, like like this is going to be a big problem. But certainly, I would say every study we feel like we got a lot of insight, um, and I feel like that was generally expressed by our clients.
Wonderful.
Jason, if I can just jump in here, you just reminded me of something that was always really interesting. That often just during the data collection and analysis
Yeah,
stage of a project, there'd be all sorts of aha moments where you think where we would say, "Wait a second, how is this going to work?" And
yeah.
and and either it would uncover aspects of the operation that we didn't know about, and often our client didn't know about, or it would highlight that real gotchas like the ones you just described for the copper operation and the railway that oh, we need to think about this more carefully.
Absolutely. Actually, thanks. I'm glad you brought that up. I usually touted that as being one of the most beneficial parts of a simulation study was going through that data collection phase, because it really made the client. Thank you. Like often what you do is the client hires you and they think they got all the answers, and then when you start asking them, like they have to start thinking about how every little bit of the supply chain works. A lot of parts they're not responsible for, and then it in itself creates a lot of value. Uh, Cameron Locke, can you describe what I called Ausenco's world-class methodology? Yeah, I just feel like Ausenco had there had been so many studies that had been carried out by Ausenco, by Harry's group over the years, that they had a really well-established way of working. So at every, so there you'd typically break a simulation study up into phases. So there'll be the data collection phase, and then the development of the conceptual model, or what we would call a design brief, which would sort of document all the inputs and logic into the model, but sort of a separate document. And then the construction of the model itself, and then the runs, and then the results and the conclusions. And so at every stage of that process, errors can come in. Like you could make a mistake analyzing the data, and it could easily flow through, and then you notice it when the results look funny, and you got to trace it all back. So we had a really great system for documenting everything with version control, as well as uh, doing what we call independent in sort of in-house independent technical reviews. So getting somebody who wasn't part of the project to check one one of the documents, like and so we review the data collection. We call it a data book. We'd review the design brief. We'd make sure that transferred into the model correctly. We used uh, we'd have people check the model and make sure it lined up with the design brief, et cetera, et cetera. So that was a big part of it. And then also just the sort of like the number of studies really led to sort of this, like, well, this was our standard approach, and it was kind of a, you know was institutionalized. I'll put it to you that way. It was an institutionalized approach.
Yeah, thanks for that. It's really important to get the wrapping processes around the use of a simulation model right, because as you say, errors can get through in all parts of the project, and having good processes around the use of a model is good.
Mm-hmm.
So yeah, thanks for that.
Yeah, for sure. Mark asked, did you have any type of black box optimization for large number of decision variables, or was it more just analyzing sets of predefined what if scenarios? No, we did the former, Mark. We would I mean, it sort of would depend actually on what the study is and what the out basically a lot of times we did do these sort of black box sweeps of different variables. So LNG terminals, that was one where they're looking to optimize. Usually it might be optimizing the number of LNG compressors, the number of like they call those trains, the amount of storage, the amount of tank storage they need, versus vessels and floating storage. And so that sort of comes to mind as one example of where we would sweep all of these different decision variables to sort of see what came out of it in terms of optimums, in terms of reliability of throughput, and minimum capital requirements.